Okay, let's look at an example here with arest. Arest is another plant growth retardant in this case. It's actually often used on bulb crops, lilies, things like that. Sometimes on bedding plants. In this case, let's do some additional things. We have arest, and the active ingredient in arest is ensimidol. And it actually is, and this is one of the reasons this is an expensive growth regulator. It is a 0.0264% solution. So in other words, it's 0.0264% active ingredient or ensimidol. And one of the things you'll see on the label with this is that if you're doing a spray application, one of the recommendations is to apply the volume that you apply of whatever the concentration is. The volume of that solution applies about a gallon per 200 square feet to get that good coverage. Well, let's say you have that, and let's say, okay, looking at and this is very real world, so we look at our recommendations for the crop. And the recommendation for that crop, and this would be a common recommendation, says that for a foliar spray, do an 80 part per million application. And yes, do the 1 gallon per 200 square feet coverage of that. And it's kind of telling you the volume to apply, which, by the way, this concentration and that volume is what makes up the dose. And when you are in the learning unit for the growth regulators and you see Dr. Whipker's little discussions about dose, that's what he means. It's both the concentration and the volume rate you're applying it out makes up that dose that you're applying. So we know these two things. So how do we go about doing it? Well, suddenly we've got this problem. We've got gallons. And ppm is really a metric because it's milligrams per liter. So we're mixing all this English metric, so we run into a little bit of a problem here. Well, let's figure out how to deal with that. I forgot to tell you something here. My apologies. Let's say we've got to apply this to 10,000 square feet. How's that? So that's the area we need to cover. Well, if we've got to cover 10,000 square feet, we need a gallon per 200 square feet. We divide that, and that would mean we need 50 gallons of solution, because there's 50 times 200 is 10,000. So if we need a gallon per 200 square feet, we've got to cover 10,000 square feet. We need 50 gallons to cover that. Well, again, we're still in English, but we know there's 3.79 liters in a gallon. So if we multiply that, we come away with 189.5 liters. That's the total volume of solution we need to cover that 10,000 square feet, following that recommendation of a gallon of the solution per 200 square feet. So here we've got our volume we need. We've kind of gotten through all of that part. Well, let's say then we wanted an 80 ppm solution. 80 ppm is the same thing as 80 milligrams of active ingredient, which in the case of arest is ensimidol, per liter. Okay, so that's what we need there. Now, we've got to deal with this whole percent thing. And if you recall, again, 0.0264% is what's on the label. Multiply that by 10,000 because 1% is equal to 10,000 ppm. So we're doing that scenario again. We come out with 264 milligrams of ensimidol, or active ingredient, per liter. Or if we divide that by 1,000, we get 0.264 milligrams AI per mil. So again, we just did this little label thing. So we need the 80 milligrams AI active ingredient per liter, and let's do the division here on the smaller number. You could do either one of these, but so the 80 milligrams per liter divided by 0.264 milligrams active ingredient per milliliter. Again, remember, these cancel out, these flip. And when we divide those two things, it should come out with about 303 milliliters of A-rest per liter. And we need, I'm going to round this to 190 liters, which comes out with a really big number of 57,575 mils of A-rest is the total we need. And if we divide that by 1,000 in order to make it liters, we need 57.6 liters. So we need 57.6 liters of A-rest into the tank and then bring it up to its final volume of about 190 liters with water. And then we take that solution and we spray it uniformly over that 10,000 square feet. And that will provide us, we've got the concentration right, we put out the correct volume, and that would give you the recommended dose for that crop. So again, all we went in, since we had this gallon per area thing, we used that information to figure out then what the total volume was we needed. We came back down, we did the little label thing where we went from percent to milligrams active ingredient per liter or per milliliter. And then we divided what we needed by what's in the bottle to come away with how much of that product we actually needed, just like we did before.